Hello, everyone. On behalf of the LAC Program Committee, I will moderate this third keynote session. I want to start by acknowledging the mainland territories and islands in Chile and the long-standing significance of these lands for multiple indigenous cultures who coexist in the past and present of this country. I also want to acknowledge the human-centered principle embedded in how these cultures conceptualize learning, particularly the Mapuche culture, in which education is seen as a vehicle for identity construction. Considering the distribution of conference participants worldwide, I also want to acknowledge the traditional lands of other indigenous people and invite you to reflect or find out what learning means for their culture. So having said that, I would like to introduce our keynote speaker today, Pierre Dillenbourg. A former teacher in elementary school, Pierre Dillenbourg graduated in educational science from the University of Mons in Belgium. He started his research on learning technologies in 1984. In 1986, he was one of the first in the world to apply machine learning to develop a self-improving teaching system. He obtained a PhD in computer science from the University of Lancaster, UK, in the domain of artificial intelligence applications for education. He has been an assistant professor at the University of Geneva. He joined EPFL in 2002. He has been the director of the Center of Research and Support on Learning and its Technologies, then academic director of Center for Digital Education, which implements the MOOC strategy of EPFL, over 1 million registrations. He is full professor in learning technologies in the School of Computer and Communication Sciences, where he's the head of the Chile Lab, Computer-Human Interaction for Learning and Instruction. He's director of the leading house ULT, which develops technologies for dual vocational educational systems. With EPFL colleagues, he launched in 2017 the Swiss EdTech Collider, an incubator with 80 startups in learning technologies. He co-founded 5 startups, thus consulting missions in the corporate world, and joined the board of several companies or institutions. In 2018, he co-founded LEARN, the EPFL Center of Learning Sciences that brings together the local initiatives in education and innovation. He's a fellow of the International Society for Learning Sciences, and he's currently the Associate Vice President for Education at EPFL. So now, Pierre, the floor is all yours.
Merci, Isabelle. Can you hear me correctly?
Yes.
Yeah, thank you very much. Yes, in the 80s, machine learning was beautiful. It did not work, but it was very elegant. Anyway, I've seen the participants, some old friends, Phil, Stephanie, Dragan, Anushka, so a good morning or afternoon to all the people I know. I want to talk about classroom analytics, and which is not analytics for individual adaptation, but for helping managing classrooms, orchestrating classroom. And in the end, I will also talk about different learning analytics ratio, which is the ratio between the size of the data set that is collected and the size of the application, whether we apply to one person, to one class, to one population. But let me start with classroom orchestration and where you can use analytics. It started a bit like this. A colleague of mine had very bad teaching evaluation, and he called me. And this is not a real picture I've taken from him, but it was not so different. He totally lost attention of his class, except the first row students, those who look at you like that. And he did not even notice he lost attention. So I thought, wow, if I could give him an indicator that he lost attention of his class, you know, maybe he would do something about it. You know, every good teacher at some point may lose attention of his class, but then you make a joke or you say, gentlemen, this might be a question for the exam, and up, you get the attention back. But this one was not aware. I would have liked to have something in his pocket vibrating, saying, poor guy, you have only 5% attention left. So we did something like that. We put cameras in front of the classroom. We also put eye tracker sometimes to the teacher, and we try to predict attention. And many teachers, so it's kind of eye tracking, collective eye tracking. Many teachers in my university tell me, I know very well who is paying attention to me, and no. They believe they know, but they don't. Our students have a long training in faking attention in the classroom. So when we train a machine learning model to predict attention, so we stop the class, multiple class every, more or less every 15 minutes. We ask the student to self-evaluate the level of attention. This was our ground truth. It's a subjective ground truth. That was the best ground truth we had. Also to evaluate the level of attention of the neighbor. And we trained machine learning, and the interesting result is the following one. Basically, we use the nose direction as a proxy of the gaze, and it's pretty accurate. The distance between the nose and the gaze is rarely more than 7 degrees. After that, it's painful. And looking at the teacher is not a sign of attention. What was predictive was the co-rotation of the head. Because if the heads of the students rotate together, because they're looking at a moving stuff, and this moving stuff was a teacher. So there was a kind of first thing, can you help a teacher to manage a classroom by telling him when he has an episode of attention? Maybe most teachers don't need it. Maybe some teachers in difficulty or novice teachers might need it. Now, I stopped this. My point is we should not put cameras in classroom. That's because, we could put cameras that take no picture, that compute in real time the co-rotation. We could do that. No single image recorded. But, if we manage to do the processing in real time. But I don't know. I don't like to put cameras in class. At some point, we have to be careful in learning analytics, not to pave the road for people who might have not the same intention as we have. And then the second criticism I got is, what is the point, Pierre? Do you want really to reinforce lecture? This model of the cool lecture where everybody is watching the teacher like TED-like? Or do you want to go for a more constructivist approach? Maybe the teacher is losing attention is because lecturing is not really engaging as a learning activity, as we all know. So here is a second example. This is a classroom of the recitation session, the exercise of physics. The TA is on the right, and the students are waiting to get help. And one is doing nothing when he's continuing to work. And where is the TA going when she is available? To the guy doing nothing because he was ready to catch her. And this is physics 101. We take a few percent of the best students, and half of them will fail the first year visual physics. And we notice they spend something like 60%. Just a second, I want to hide this bar. They spend more than 60% of the time when they were waiting for the TA doing nothing. And Ahmed Alavi, who was in the lab at this moment, designed this very simple device, the lantern. When you rotate it, it changes color. So green is exercise 1, pink is exercise 2, and so on. So the TA knows where you are in the sequence of exercise. The color is the time that you spend on an exercise. So, if you ask help, you should first try by yourself for a certain time. So you should wait the number of LEDs to turn on to be quite high enough before to help them. And then when they needed help, they push, instead of stopping working, they simply push on the lantern that start blinking faster and faster so that TA can distribute the attention, especially when there are several TAs in the same room. And with this, the wasted time went down from 62% to 6%. So these are two examples where at some point the input, and that's the difference with the main approach in learning analytics, the input is not an individual learner doing some behavior in a system. The input is the classroom. the input, and the output will be the classroom as well. In the uppercase, it's a distributed display. It's located all around the classroom. And this generated the idea of the classroom being a digital system. I prefer the upper example, light information, minimal information, very modest, than the one on the bottom. As I said, camera is not my cup of tea. So that's what I just said. Basically, the learning analytics is really an individual benefiting from all the individuals before. Classroom into analytics is more a collective thing. And the goal of learning analytics is to take the system to adapt instruction, except in the case where we have open student models where we reveal the state, what the system believes on the state of the learner. Here it's quite different. The state is not to make automatic, the goal is not to make automatic decision, but to keep a human in the loop, and this human is the teacher, to help teacher through dashboard and any other technologies to make decision. So the idea is having the classroom as a system means nothing. Everything is a system. My phone is a system, my left foot is a system, my classes are kind of connected intercomponents. So it doesn't help a lot to call a classroom a system, but as we call it a digital system, basically it means there is some processing between some input and some output. And what does it mean then? If we have this model, this digital system model, what does it mean for a classroom? What is the input? What is the processing? What is the output? So the input has mostly sensors, where you capture what's going on in the classroom. The output has mostly actuators and mostly displays. But there could be other kind of peripheral display or opening automatically the windows when you notice that the quality of air or quality of attention goes down and so on. So sensors, these are all the sensors we already have in our phone, and there is an infinite list of external sensors that you can connect to your phone. Nothing special about that. Then actuators, displays are mostly dashboards, so no, that's not new. Everybody is making dashboard. My personal belief is that most of the dashboards are a bit sophisticated, too sophisticated to as compared to how a teacher can what a teacher can handle in real time, facing 20 kids, trying to maintain attention. So it needs really kind of synthetic information, simplified information. So that's basically the idea of the classroom system, nothing magic and nothing fantastic. The input is the classroom data, and the output in most of the cases is a visualization that helps the teacher orchestrating the classes. So what is the function of this output? It helps the student, the teacher, monitor and decide when to intervene. So as I said, in the system, the output is not simply the input. This is called a mirror, but it's some processing, like aggregating data over time, comparing, and so on. So the types of visualization, there are many, a few examples. In the lantern example, we compare two outputs. One was the distributed lantern on the top that you have seen. One was a centralized one. Exactly the same information. The color, the height of the bar, the level of exercise, exactly the same information, centralized or decentralized. Both of them actually reduce the wasted time, except that the bottom one, because we are still in a school with 70% males, they saw it a bit like a board game, kind of a competition stuff. You can have, as above, visualization in real time. Things should move in principle, where you see in real time what your students are doing. And in the bottom, this is the attention in my classroom, post hoc replay, donation discriminates reflection in action. The teacher is facing the enemy, is there in the class, and he has to monitor what's going on. And if they work all on the laptop, it's not easy to realize what they are doing on. And then reflection on action after one in the evening, if you want to reflect on your teaching process during the day. Most of the dashboard are on a display, so they need focal attention. I believe a lot into using peripheral displays, something quite minimalist on, it can be something changing on the wall, on the ceiling, a plant that is actuated and can reveal it's like that if the class is doing badly, and it flourishes when the class is doing well. The teacher focal attention is very much used to manage the class. So the more we use peripheral attention and ambient display, as we call them, the less we overload the focal vision of the teacher. It can be public or private. I will describe later on the above example where the teacher uses the dashboard to discuss with his students. Of course, there are quickly some ethical data protection question. If one student is misperforming, do you show it to the rest of the class? So most of the dashboard are on the laptop or the tablet of the teacher. In terms of orchestration, the public dashboard are extremely powerful because you really involve the classroom itself. It's not only the teacher that regulates the classroom with information, it's the classroom itself that is being involved. But that requires having some classroom spirit where you dare to do so. In this small classroom, there is in vocational education, there are 16, so they know who is good and who is less good. So it's not really disclosing private information if at some point somebody see that one of the team was performing less well on the dashboard. But it's not possible everywhere. There may be some concern about that. Then I like the work of Kevin Holstein. I think you have seen it, where actually he put the dashboard on.
When a teacher glances around the room, Lumilo allows them to instantly see when students are currently struggling in the software, doing well, or when they're.
So this is a head-mounted device for the teacher,
without an intervention
where he knows what students are doing.
In addition, Lumilo lets teachers see when students have been idle for a while or are currently misusing the software by abusing.
So can himself, one of his papers is called "My Teacher is Cyborg," recognize that working in the classroom with a head-mounted device may be a bit too much, but that's the idea. Is if you have a dashboard on the teacher desk and the teacher gets stuck behind his desk to benefit from the dashboard, then you lose something, because moving between the students is important. If you give him an iPad, you solve this problem, but he has to carry the iPad all the time. So, so basically, classroom as a system, you collect students' data at the class level for visualization, but also teacher data. I like this work from a colleague, Isabelle Sarad. She monitored the position of the teacher in a classroom. It was a chemistry or biology lab. So these are the blue boxes are work benches, the green dots are the students. And it's quite interesting. You see that, first of all, the teachers doesn't go much to the last row. So the students are kind of neglected, and it's quite asymmetrical. He goes or she goes much more on the right-hand side for us than on the left. Why? We don't know. But if you show this to a teacher, maybe he or she has an explanation. Maybe there are some cables. Maybe there are some students who had more difficulties on one side, or he has some explanation. The point is not to interpret the graph. It's a mirror. You send back the information to the teacher who knows the context and may interpret the information in the context. That's another one that we've done in the Lausanne American School in Switzerland. Same again, the time spent by the teacher in different positions, quite asymmetrical. So another case where we use teacher as input is we gave to This is with Plato on the picture. He was doing activities in this space with different teams, and we gave him eye trackers. We gave him some beacons in his pocket to measure his position, his movement, and so on. And we kind of extracted automatically his activities by applying machine learning on the raw collected data. And you see the different activities he was doing, task distribution, explanation, questioning, and whether he was working more with the entire class or sometimes more with a small group. So it's a way of extracting the pedagogical scenario from the actual behavior of the teacher. I don't know if you have that in your project. You know, the teachers tell us, some teachers tell us, oh yes, but I make a 5-minute introduction first, and this 5 is always 15 or even more. So extracting the behavior of the teacher. This is another one where they were checking the understanding of the student during the lesson as perceived by the teacher and as perceived by the learners. So collecting data from the students and what's going on in the classroom and trying to visualize it. That's another one that's a commercial product. I don't know the developers, called Visible Classroom, inspired by the visible learning from Jonati. Same, you know, here you see that somebody has been speaking 43% of the time, 160 words per minute. I don't know if I can achieve 160 words per minute. So I come back to the main question now. So we can do that. Nothing is rocket science in what I've shown you. We collect data from the classroom and we use it to regulate the classroom. It's just, I'm not selling a new technology here. It's an idea that is now quite widespread. I just, let's say, crystallizing the idea. Now I'm back to the question, you know, constructivism or lecturing. And I want to show some example. One is coming from the work that we have been doing with carpenters. The teachers of carpenters for vocational education told us, with a new study plan, we have to teach statics. We have three hours. In a university, civil engineering, that takes 3 years to learn it, but we have to do it with people who have not been very high in school, and they have 3 hours to learn it without any mathematics. Can you do something to help us? So we designed some virtual reality system where you can, you know, it's augmented reality, sorry, not virtual. So you have a real beam structure and you put loads on the roof. You have snow on the left, you have spring being compressed or extended, and you can explore this by adding loads. So there is more snow usually on the north panel. There is more, the solar panel, you put them on the south pane of the plane, and so on and so on. Very cool thing to learn by exploration, to learn the law of statics. No. Here is the video. So this is my structure. I will put some weight on this beam. And you will see which beams are now being compressed, extended. You can do many things. You can decide to change the wood. Maybe put a more expensive wood. You can put more weight on your load, more expensive or bigger beams, and so on and so on. What you can also do, because we don't see forces, what you can also do is to exaggerate the deformation. So how would my beam look like if they were not made of wood but made of marshmallows, so that you realize what would happen, and so on and so on. Now, question. Will any carpenter discover Newton's law by playing with a simulation like that? No. It's super cool. It's quite interesting. It enables them to explore the field, but they will not in 1, 2, or 3 years rediscover the principle of statics. So my point about Piaget versus TED is something that John Bransford and Dan Schwartz have expressed as there is a time for telling. So if you do the problem-solving activity, and I will come back to what it means for orchestration. When you do a problem-solving activity like that, they will not by themselves rediscover the rules. That's over-optimistic. Learning with a simulation is very complex. Tom DeYoung has shown that quite intensively. But there is a time of telling. If after a certain time of exploration, where they did not really make eureka, they did not discover, but they felt, they kind of noticed and so on. And then when you give the lecture, basically you answer the question they ask themselves. And this lecture is effective, very effective. And my question is, can we help the transition between problem solving and the lecture? Similar study, predictive failure with Manu Kapoor. Instead of giving the direct instruction on what is the standard deviation, they let them explore. He asked, these are 3 soccer players, the number of goals per year, which one is the most consistent? And so these 2 comparison, direct instruction versus exploration, call that predictive failure, because none of them shouts, Eureka, I found it, no? And in terms of the ability to compute standard deviation at the end, there is no significant difference. But in terms of conceptual understanding and transfer, there is one. So what is the connection between this pedagogical concept, there is a time for telling, and classroom orchestration and technologies? And the point is, if the lecture, if you let them explore, and then you come with a lecture that is not grounded in what they've done, then a transition is not made. And that's very difficult. It's very difficult. You cannot come with a PowerPoint ready. You need to kind of build in real time the second part, the formal part, based on what they've done in the first part. And that's where you need to collect. Does the technology help you to aggregate the data during this exploration phase to facilitate your job as a teacher to compare, comment, criticize, and step by step go to the theory? I will take a second example, still in vocational education. Sorry, some of you have seen that already many times. It's about training logistic assistants, people who work in a warehouse, and they have to learn logistics, the optimization of storage in a warehouse, which is pretty abstract for these students who are quite very low achievers in school. So we designed this augmented reality for training logistics. So this is my warehouse. On the right, this is where the trucks leave when the trucks arrive, and this is building here it becomes red because the distance between 2 shelves was not big enough for a forklift to be able to rotate. So there is an instruction. On the left, this is the exercise you have to do, optimize storage, and once they're ready, they can run the simulation and see the life in the warehouse. That's quite already an old system we've developed. You see the forklift, they go, they pick the forklift. But the reason why I will use this study here is to explain this debriefing phase. So to make a long story short, we compared this super cool augmented reality system with paper and had no significant difference. And what was missing is the debriefing phase. The fact that the teacher can build his principle, he has to teach some principle of storage management, and he can ground this in the activity of the learners. And what you see is this picture you have seen before, where you have 4 teams that have been working on 4 interactive lamps. So you see horizontally, so vertically you have the 4 teams. Horizontally is the different layouts of the warehouse they have been designed. The color bar that you don't see very well indicates how much they've been tinkering versus thinking. So if they move too much, it means they're playing with the tool and they're not really reflective. So that's a tool for teachers to regulate the classroom, to tell them, no, don't run. Think about it, make an hypothesis. On the bottom, you can select 2 of the warehouse and compare storage surface and so on and so on. And with this, we obtain, with this debriefing support for the teacher, we obtain significant results. So basically, the classroom analytics there was collecting the data from the 4 interactive devices and aggregating for the teacher, not for the usual goal of monitoring and intervention a little bit, but also for the goal of feeding the teacher with the substance he needs for the debriefing, comparison, explanation, asking the students to justify their choice, and so on and so on. So this is, you see a zoom on the different parts of the dashboard. So there was a monitoring during the problem-solving phase, but the one point I wanted to introduce is the debriefing phase. Using classroom analytics, not only for regulation, but for enabling the debriefing phase. Here is an example for my class where I have many students in an HI class, and I want to compare interaction styles. So I asked them to do the same task with 4 different interfaces, a command line on the top, a form on the bottom left, a drag and drop on the top right, and a graphical interface on the bottom right. Just doing the same task, ordering 3 train tickets with 4 different interfaces to feel the difficulties and pain on different interfaces and advantage of different interfaces. Then I asked them to classify the favorite interface, the 4 of them, based on their preference. And so first, I asked them to do these 4 tickets. Then I make teams of 2 people who disagreed. The system automatically makes pairs of 2 students who disagreed on the order on the preference for the different 4 types of interface. The room is full. People cannot move, so the system generates, if there are 100 students, the system generates 50 chats so they can argue online, and you hear the noise of the keyboards. And so this is what the socio-constructivist call the social cognitive conflict. Then after that, I give them the data because I know the number of errors, the time it takes to order tickets. So I ask them to argue again, but this time by having the data themselves. And then there is a debriefing phase where I can comment all the results of the previous phase and bring the theory of the model of Schneiderman in this case. So this lesson plan, as many lesson plans, finally is a sequence of activities. Some of them are class-wide, some of them are individual, and some of them are in teams. And the role of the analytics is to collect data from one activity to feed the data to the next activity. So the individual was ordering train tickets. This has provided data to make teams of 2 who disagree, that provided data to show their own performance, and provided data for the lecture at the end so that I connect the theory to what actually they've done with these interfaces. So when at the beginning I said the role of the system is monitoring and intervention, another function is debriefing, and then the last one, which is time management. This is in one of these exercises when you have 100 students in the class and you say, okay, I give you 10 minutes, and after 8 minutes, you say, have you finished? After 10 minutes, some of them have not finished. So what do you do as a teacher? If, let's say that 20% have not finished, you say, well, I gave you 2 more minutes. But so because you don't want to lose 20%. But at the same time, 80% of your students are wasting their time and they start reading the email or whatever. So the goal of analytics here, this is a data that comes from real data from my class, is to help the teacher to predict when waiting 5 more minutes or 2 more minutes will not bring any increase of completion, will not bring many more students who have completed the activity. So I show it again. So blue is those who are working, and red are those who are completed. And in a very simple way, when the curve becomes flat, then there is no reason for the teacher to continue to wait, because that will not improve the completion score of this classroom. So that was the 4 key points I wanted to illustrate when I say the classroom is a system. When I say analytics help classroom orchestration or classroom management, these are the main 4 functions that I was talking about. Now, in the 5 minutes left, I want to show you another example. This one is more new. It comes from my lab. It's about more traditional learning analytics. It's not classroom, but I will use it in 3 minutes. It's about handwriting. About 25% of 5 to 12 years old children have problems with handwriting. 8.2% of them are called dysgraphic. It means they have very severe handwriting difficulties that will bring them to a professional therapist. And even worse, usually it takes quite a while to detect the problem, because the kids start in September. By Christmas, the teacher has some hesitation. In February, we'll call the parents saying, your child is quite late, and then they will take an appointment at Easter with a therapist, and the poor child has wasted 1 year. And if you have problems handwriting, you have problems in everything at school, because even for mathematics, for everything, you need to write. So the cognitive load of handwriting will absorb all the resource you need for mathematics, for instance. So in every country, this is the French one. It's actually initially a Dutch one. In every country, there is some kind of test to analyze handwriting. This is the handwriting of the child on the left, and you see the therapist. He will grade his 5 sentences according to certain criteria, make a sum, and above a certain threshold, this child will be taken in charge by the Social Security. And this test is slow. It takes 20 minutes for a therapist, time that he could rather spend with the child. It's subjective. 2 therapists only agree in 60% of the case. And more importantly, it neglects all the dynamic of handwriting. The fine motor skills. It's only based on the final image, the static image. So what we did is very simple, and we asked children to write on a tablet. And then when we had about 1,000 of them, some of them dysgraphic, some of them non-dysgraphic, we trained various model, convolution, recurrent, and to extract features that predict severe handwriting difficulties. Some of these features are static, like the shape, like what the human eye would analyze, but the other one are dynamic. So the speed. So the left-hand side is the kinematic left-hand side is a dysgraphic child. He has more frequent variation of the speed. same for the pressure, and same for the tilt of the pen. So the system extracted very sophisticated features that the human eye cannot perceive, like the second derivative of pen pressure or these kind of things. And quite interestingly, we find that two kids who are both at the same global score actually might have totally different difficulties. So they should not have the same remediation game because one has more problem of speed, another one a problem of pressure or tilt or whatever. So in this, for each difficulty, we actually have 10 games that do not look like school because these kids are already burned by school. They don't want to do they don't like to write because writing is a punishment for them. So like they're making a G there, but they don't notice they are just escaping to the bad guy in his balloon. So some of them practice pressure, only the pressure, some of them the angle, some of them the speed, some of them the accuracy, and so on and so on. That's a more typical example of learning analytics. When we trained models on thousands of children in French, English, Italian, German, we actually had also success in Kazakh, written in Cyrillic, and with bilingual kids in Hong Kong writing in Chinese and in English. So we collected data with thousands of data and we use them for an individual learner. And of course, for the teacher, he needs a classroom dashboard so he can zoom on the progression of his classes. So, and that's my final slide. That was a notion of ratio that I discussed with Richard Davis, which is a postdoc in my lab. Most of learning analytics have a ratio of n to 1, like by the knowledge tracing. We train, the one I showed you in Dynamics. We train model with many learners, and this model is being used for the optimal choice for learners. The example I gave you on classroom analytics for measuring attention or predicting completion time, we can train to many learners, and it's not used for predicting one learner, but for predicting C, which is the number of learners in a class. Forget the stupid notation C and P and whatever. Then we had one-to-one in the past. When we did student modeling, some of you were not there, but in the 80s, 90s, student modeling was basically, we use the data of one learner that we analyze to interpret it and predict and make decision about the same learner. N to 2, what we did in eye tracking is to use data from many pairs to predict the level of mutual understanding in a given pair. So in a nutshell, efficient pair working well, when they speak about an object, they tend to look at the same object at the same time, so synchronizing with two eye trackers. And so we collected data with many people that could be used to predict something for the state of collaboration of two people, N to 2. Dashboard are more classroom to classroom. It's not really that we import data from a massive data set. It's we have data from this class to this class. We could say that social network analysis is N to N. And one of the last thing we did in my lab is, can we mine the web, Stack Overflow, job ads, MOOCs, to predict that new skills will be on demand in the job market in a couple of months and make the education system more agile. There, actually, the output set is larger than the input set. The N is the thousand of posting in job ads or Stack Overflow, but S is a society is extrapolating the result beyond the sample where they've been taken. So I thought it's interesting to consider this range of ratios as a kind of opening the scope of learning analytics to a very broad range of research questions. And I think that's it. Yeah, that's it.
Thank you, Pierre, for your insightful presentation and for all the different examples that you provided within classroom orchestration, both different educational levels, different types of knowledge domains, and also like your insights about how data can empower teachers so they can empower, impact better our learners. So there are already some questions in the Whova Q&A. Just as a quick announcement, it's like we're going to have about 15 minutes now for questions and answers, and then for those who could stay, we will have an extra 30 minutes as well to extend these conversations. And I would like to start with a question that I feel that it's also aligned to some concerns or some questions that we raised within the conference topic about privacy, fairness, transparency within learning analytics that in a way are also related to trust from our users. So one of the questions in the Whova chat, I see Stephanie with her camera on. So if you want to, you can do the question if you would like.
Oh, okay. Well, thank you. Hi, Pierre. Good to see you too.
Comment vas-tu, Stéphanie?
Bonjour, bonjour. So my question was, how do you convince teachers that this kind of data is for them and not some assessment of their teaching? We know that these kinds of systems often turn into surveillance systems, even though that's not how they were initially designed. So how do you convince teachers that's not going to happen?
It's a good question. I don't have a good answer. I don't have a good answer. I'm thinking about what we do know. For instance, on campus, we have, as probably in many universities, Jupyter notebooks became the kind of ubiquitous tool. Some of them used for advanced machine learning, some of them just as a demo tool, some of them they leave 2 lines in a physics algorithm and the students can just change parameters. So it became a very huge tool. And what we are doing now is actually making a tour of the teachers, asking, what would you like? When you have a room with 120 students using Jupyter notebooks in front of you, what would you like to get? And that doesn't work very well. This participatory design is supposed to be, honestly, that doesn't work very well. I think the next step, we will bring them example and tell them, would you like this? Would you like that? Because asking them to imagine what the dashboard would be useful. But so my only answer is, can you start from a problem of the teachers? And so that's what we are trying to do with this Jupyter notebook. Now,
I guess I would push you here, though, to think about the differences. Sorry, that's my dog. To think about the differences between university instructors and, say, instructors in the K-12 space. So at least in the U.S., university instructors have a fair amount of autonomy and decision-making in their own classrooms. In the K-12 space, that's really quite different, and teachers often feel pressed about performance measures and who's going to collect them and how are they going to be assessed.
I would have one answer would be minimalism. Like, imagine these things where you show them a map of where they've been in the classroom. I would like to do the same with eye tracking. A good teacher is always looking at all the kids. He's distributing his gaze more or less evenly. And some teachers, at some point, they lose any ambition for some children. They say these children are, and these children will fail. If the teacher has no expectation, the child failed. And this is obvious. And I would not give them a detailed things. I would not give them a big pedagogical blah blah. I would print the map of the visual attention of the classroom, paste it on a bottle of wine, and bring the bottle of wine so that when they have a glass of wine, say, oh, this today I have. But I have a nice anecdote. Once I gave a talk to a K-12 school, and being very careful, Big Brother, data protection, and so on, very careful. And at the coffee break, 2 teachers came and said, Mr. Dillenbourg, eye tracker, sensor, EEG, you can put whatever on me. I agree to do everything. So there are also some teachers who are willing to have fun and to make experiments. That's not the majority, I acknowledge.
Thank you, Pierre.
Thank you, Stephanie, for the questions, and Pierre for your reflections. In that line, one of your recommendations regarding this question was minimalism. And you mentioned some things that related to design of like how to collect data. And there is a question from Sebastian. I also see your camera. If you want me, I can read it. If you want, you can do it yourself.
Oh yeah, I can just go ahead. Hello, Pierre. Thank you for your presentation. It was a pleasure to listen to you. My question, is along the lines of what Stephanie just asked. So I'm coming from a more like a feedback perspective, and you said something along the lines of, okay, you prefer more like minimalistic indicators for the teachers, but I was wondering whether these indicators help, or to what extent can minimalistic indicators help teachers orchestrate, because they are lacking information, sort of. So I was thinking more feedback might be more helpful, but on the other hand, I mean, they're also prone to overloading the teacher. So I'd like to hear your idea on that.
I have a good example. The lantern that you have seen, huh? That indicates quite in a fuzzy way the level of time they've been working, the level of time they've been waiting. And it's not we could have a small display that displays the exact number of seconds. Or we could have an app, or for the TA, say, next in queue is table 5, next in queue is table 6. So we deliberately reduce the amount of information to make it more acceptable. So this is minimalism. Sometimes we call it modest computing. In computer science, we always want it more accurate, more precise, and sometimes making it less precise. And it's just the TA has some idea about who has been waiting all along, but maybe not so clear. We could give him the exact waiting time and the exact order. I would not like that as a TA. I don't want to be a robot being driven by an iPhone. So by having this kind of mid-level of information, there is some information, not extremely accurate, but we still keep the TA in his role of interpreting. Maybe there is one team that has been waiting for more time, but you have been already before 3 times with this team, so you say, okay, you will wait a little bit, and so on and so on. So leaves, I would say, there is one answer is cognitive load, of course. If you give too much information, you overload, and I think many dashboards do that. But one is acceptability, something in the background, and almost poetic. These little lanterns are almost poetic. They don't look as Big Brother is watching you. So we had no reaction from the TA saying, "Oh, are you going to control us?" We had Stephanie. They did not say, "Oh, with that we can," but we said, "Okay, but with that we can say to the teacher, the average waiting time of the students was 20 minutes out of 140 minutes. No, 90 minutes. You need more TA." That's the kind of information we could provide to the teacher. They've been waiting. The students have been waiting too much. You need more TA.
Yeah, that's great. Thank you so much. I'll take away the idea of modest computing. That's good.
Yeah, we always want more, but quite often less is better. Actually, in computer science, we always want more. Yeah.
Well, in those same lines, and thank you, Sebastian and Pierre, for this interaction. In those same lines about this idea of less is more. There is a question in Huba from Dane about, is actually reducing the complexity of data critical to show simplified student status labels, like a smiley face or versus a warning icon? Has showing less information to instructors ever led to unintended uses of classroom analytics, when less could be bad? That's kind of like a simplification of the question.
No, we agree that less can be bad. I mean, it's an optimization thing. But the depending on who I'm talking to, I would have opposite discourse. So some people I would say, no, give a bit more. But talking to people in learning analytics that are mostly geeks, I need to rather tell them, maybe doing less is actually, and it's certainly less in terms of the accuracy of information. It's also, I come back with the notion of peripheral vision, let first the eyes of the teacher should look at the children, not at the display. That's the main role of the teacher. So if at some point you can have something beam on the ceiling, you don't look at the ceiling, but suddenly, if this is peripheral vision. If there is something there static, I don't see it, but if it's shaking, I see it. So peripheral vision, something vibrating in my pocket, not too often, not, there is one channel which is too busy, which is the focal vision of the teacher, and let the teacher focus on the kids and try to see how we can use the rest of his senses. Some electric shock, for instance.
Well, so at the end, in a way you have this signal, but educators need to take a look at the face of the, have their own information in order to make an interpretation of this signal. But here's a question about that from Natalie, how can we train educators towards more data literacy and competency with respect to classroom analytics?
I don't know in your country. In my country, they go to the teacher training university or teacher training college, and they've over 4 or 5 years, they have maybe 80 classes to take. And these 80 classes, there is 1 or 2 on learning technologies, and 78 that use absolutely no technology, no dashboard, no analytics, and so on. So these students understand the point. Digital education is a blah blah, but I have 78 courses versus 2 who does not use digital education. So I think that really bringing our digital tools, my gadget, if you want to, not in 1 or 2 showcase in the teacher training college, but having the professor of pedagogy, sociology of education, history of education, philosophy of education, didactics of mathematics, didactics of French, and so on. Having all these professors using this as a natural tool, then I think now what we do is kind of too late. They come out, they had 1 or 2 classes on digital education. They have no problem using computers. I don't know in your country. In my country, you don't live without a computer. You cannot book an airplane. You cannot book a ticket concert. You cannot book a train ticket. So you die. You cannot save your holiday picture. You cannot do speed dating. You die without a computer. So the teachers know to use a computer. The question is, how do I orchestrate my class? What do I do? And no, you're not going to sit kids for 50 minutes in front of an iPad. No, you are going to make an introduction, then they go in the forest, they take picture of mushrooms, and then they come back, they make teams, they make a poster. And this idea of orchestrating a sequence of activities, some with technology, some with not, this idea is not present in the school.
Yeah, thank you for that reflection. We are 1 minute to hit the end of the session. We can stay here, people that we have 30 minutes more for questions and answers. So please keep posting in Huba. Also, you can use the Zoom chat, but just announcing. So if people have other sessions, but we will stay here in this Zoom. And actually after the 30 minutes, we'll have a panel moderated by Javier that is titled, Where is Learning Analytics Going? Examining Values, Goals, Practices, and Perceptions of the Field. So everybody's invited to stay, but whoever needs to leave, we hit the moment, and now we're going to keep question and answers over here, just letting you know. So, yeah, in those lines, just going back to your answer, actually, yeah, I think that, for example, in Chile, we have a lot of programs, like ministry programs, in order to deliver equipment, and obviously there is the use of devices in your daily life, according to teachers, but I would say that there is this, there are aspects or gaps in initial teacher training. So at the end, you try to cover too much during teacher development, but there is something also about encouraging teachers from their initial teacher training in order to make the informed, database decisions within their classroom planning in a way.
If I can reply, I think in the teacher training, we give classes that the future teachers are not ready to listen. I think if you take a class on philosophy of education or history of education 10 years after being in service, then you will really love it. If I really I would focus, and many people will kill me for that, I will focus the teacher training on the job of managing a classroom, orchestrating a classroom, and with and without technology, or can you do it without technology? So that's so one way to make space in the teacher training program is maybe to keep some of the topics when they will make sense to a teacher, which maybe 5 years later, 10 years later, the time at first is survive to classroom management.